It can be instructive to go back to some of the graphs that were the wrong answer and figure out what the correct formula should have been. For example, if we go back to 3a here, we'll find out that this is actually a graph of the equation y equals 2 plus the tangent of x. Well, how did I figure that out? Well, first I noticed that the inflection point, or the point of the curve which is the flattest, which usually would occur for just tangent of x at the x-axis, is actually translated in the positive direction by 2 units upwards. So this is actually the inflection point, the flatter point of the curve. It's over here. It's 2 units above where it should normally be. So we've got a 2 plus in this graph. Also, the graph, once you adjust for that, if we make this our x-axis and ignore the fact that it's translated up by 2 vertically, we find out we get exactly the curve of tangent of x. We get a curve that has a period of 180 and whose zeros are at 0, 180, 360, etc. That is tangent of x. So A represents a curve which is y equals 2 times the tangent of x. Let's go down to curve C in the same question. We see here a curve that also has a period of 180. So if there's a period of 180, it means that there is no coefficient that is multiplying x. X is just x. Okay, so we don't have a vertical shift, so this is just y equals the tangent of x plus some kind of a constant, or minus some kind of a constant. The question is, what is the constant here? And, well, you tell me. Take a look at this curve. It's basically the curve of tangent x shifted to the left by 45 degrees. Okay, if it's shifted to the left by 45 degrees, then that means we've got x plus 45. So this is the formula of y equals tangent of x plus 45. Now, what's another way we could have perhaps found this out? Well, we know that there's a zero of this curve occurring at 135 degrees. So if we didn't know what 45 degrees was, and we only knew it was x plus some kind of a constant, okay, what we could say is, well, we know that when x is 135 degrees, we're at a zero of the function. Well, we know the zeros of the tangent occur at intervals like 0, 180, 360. So we could set this equal to 180, let's say, which is a convenient value. Subtract 135 from both sides and get that c is equal to 45. Okay, so there are different ways to go about thinking about it, but in general, this is a pretty interesting exercise that will help you in developing your skills further in terms of trying to figure out what the equations of curves are. Why don't you go ahead and try to work on D? Take a look at this graph. Try to figure out what the formula for this graph is. Notice that it has intercepts. X-intercepts at 180 and 360. Figure out what its period is. Notice it's got 3 periods between 180 and 360. Go ahead, try to come up with its formula. In the next video, I will solve it for you.